So thank you, Teresa, and thank you for having me and inviting me to speak about winter camelina. So I'll be talking about some of the work that we've done and winter camelina in general as a crop to diversify your winter cover crop systems. So first I'll talk about what I do. So I work on cover crops and specifically sort of the intersection of precision ag and cover crops and conservation crops and how we get them on the landscape. So two of my overarching goals for my research is developing and refining management strategies and tools to overcome some of those limitations and increase the use of cover crops on the landscape, and then also to diversify dairy forage cropping systems to reduce environmental impact while providing quality feed for dairy production. So, so one of the crops that I am currently working on is winter camelina. So why winter camelina? Why would a grower want to integrate winter camelina into their crop rotation? So for one, in colder climates, it's one of the few cover crops that more reliably overwinters. And when I say more reliably, I'll speak to that a little bit more here in a bit. We have noticed some interesting dynamics happening with winter camelina in our climate, especially with this last winter that was a little bit warmer than normal, and where we didn't receive as much snowfall as normal. So I'll talk about that. And also, it's one crop that we're looking into as a way to diversify our crops, our cover crops, to reduce potential negative impact on the subsequent corn crop. So we know that, especially with small grains, but particularly cereal rye, sometimes we have concerns about what kind of impact its use might have on our next corn crop. And because we are very corn silage heavy in our state and in dairy forage production, that is a concern. So in order to alleviate that concern and get more cover crops on the landscape, we want to see, okay, what are some alternatives to cereal rye that we can integrate to reduce that impact? And then also to provide early to mid-spring flowering resources for pollinators at a time when there just aren't a lot of flowering resources, right? Especially in agricultural fields. So those are the three primary reasons that we're interested in winter camelina here in Wisconsin, at least. So we know camelina is it's a brassica. It's one of the brassica cover crops, or brassica crops. And when we look at some of the brassica crops, there just aren't a lot that will more reliably overwinter. And so winter camelina is one of those. Pennycress is another one. There just aren't very many that will do that. So how can we use winter camelina? So the first way, of course, is strictly as a cover crop, right? We get the ground cover that we want with the cover crop. We reduce nutrient losses, soil erosion. We're currently doing some work on winter camelina here in Wisconsin, looking at its ability to take up extra sort of excess nutrients from the soil, especially after dairy manure applications and after corn and soybean, specifically after corn. So can it take up extra nitrogen? Can it take up extra phosphorus, for example? And then, of course, it's used as a cash crop. So this is probably where, in terms of getting sort of a net return on camelina immediately as a cash crop, where probably a farmer is going to be most interested, right? So it can be utilized as an oilseed crop. There's a lot of interest in it as a use as a renewable fuel source. There is some production out west in Montana, Colorado, even North Dakota, on there is some winter camelina oilseed production. It's high in oil. Has a very high oil content. It's very high in omega-3s, so it's also a more healthy oil seed. And it fits within double crop systems really well. It can be grown over winter. You can plant that after a soybean or corn crop in some instances, after a small grain crop like spring wheat, and get it to overwinter and then harvest it by June of the following year. So it fits in nicely as that winter, sort of that window where there wouldn't be another cash crop growing otherwise. And you can also harvest it with a combine. There are some sort of intricacies of that, but it can also be harvested. So you don't need special equipment necessarily to harvest winter camelina. And another thing is that it is drought tolerant, which is one of the reasons there is interest in it out west. However, one caveat is it does not tolerate waterlogging. So if you have soils with high clay content or poor drainage, it may not do as well. It doesn't tend to like those heavy soils. I will say that there's the double cropping system, but also there's relay cropping systems, right? So there's research that's been done on relay cropping, and can you plant, for instance, a soybean crop into a stand of winter camelina? There's some of that research done. I have not done that research myself, but there's some information on that. And also what we're finding in Wisconsin, and I'll talk about this a little bit later, is rather than that mid-August to late October planting date, we're seeing that September to early October is more ideal for our growing conditions here in this part of the state. So how can we use winter camelina? So the third way is, and this is what I'm doing research on primarily right now, is for use as a mixture in forage. So and I'll talk about this particular study where we're looking at winter camelina in winter cover crop mixtures and their use as a spring forage. But obviously you get the benefits of that ground cover, you get nutrient uptake from the cover crop, you reduce soil erosion, but then you can use it in the spring also for a forage potentially. So there is work being done here at our center about its value as a sort of a feed in a dairy cattle diet. So we're doing some feeding studies with it. But also if you're interested in grazing cover crops, that's something that can be utilized for grazing as well. So I'm going to talk a little bit about winter survival. So it's been interesting. It's been an interesting journey the last 3 years with this particular project. Winter camelina did really well. The first 2 years, we had nice consistent stands, but what we saw this past year were highly variable stands, and hopefully you can see those photographs. But the photograph on the right is a plot where we had just a better, nice stand of camelina. That gap in the middle there is just because of our planter passes. But on the left, you see there is some camelina in there. But you can see a lot of the dandelions kind of taking over. There isn't a ton of camelina. So what we're seeing is really highly variable stands with the winter camelina because of the warmer temperatures overall, we think. But what we saw this spring, at least in this part of Wisconsin where we conducted this project, is we saw highly variable temperature fluctuations. So we went from, I think we hit maybe 70 degrees at the end of January, and then a week or two later we were below freezing, and I think we below zero during that time period. So we had really high temperature fluctuations. We had lower than normal snowfall. So we think that the temperature fluctuations, along with the low moisture and cold temps, really affected the stands. And in talking with some folks out in Minnesota that do work on winter camelina, they saw similar things out there, and we think it's just where that camelina happens to be located and how much moisture it's getting and how much it's exposed to that fluctuation in temperatures. So now I'm going to talk a little bit about its sort of forage value in general of brassica cover crops. And then I'll talk about our project specifically. So brassicas in general. So for instance, here's a little bit of information from the University of Minnesota Extension, looking at different cover crops and their value as feed. So when you compare things like a turnip, which is another brassica, you have an NDFD value of 28.6%. And when you compare that to things like corn silage or legume silage, grass silage, that's a little bit on the lower side. But you have other cover crops that are much higher than that, of course. So the reason I mentioned NDFD is research has demonstrated that lactating dairy cows will eat more dry matter and produce more milk when fed forages that have higher NDFD values. But that can depend on a number of factors, right? There are environmental conditions, timing of harvest, variety selection, And it also depends on what class of livestock that you're feeding this forage to. So that's just one example and kind of a range of figures that we're looking at here for forages of cover crops, forage value of cover crops. And this is from North Dakota State University. So when you look at the value of these different sort of cover crop groupings or cover crop types, in terms of either their grazing value, their hay value, their haylage/silage value, they really kind of did a nice summary of, depending on the type of cover crop you're interested in, you're growing, where does that really fit in terms of if I have livestock and I want to utilize that cover crop as a feed source. So in the case of brassicas, they're suggesting that for grazing, it's a good option value, and for haylage, baleage, silage, it's also a good option value. But quite frankly, we just don't know a whole lot about the value of some of these cover crops for feed, and that's some of the work that we're trying to address here at our center. And I think there's a little bit of caution to be had as well in terms of feeding brassicas. If you do have animals on your livestock on your farm, if not grazed properly, brassica can cause some animal health issues, right? So introducing grazing animals to brassica fields or pastures slowly is important. And also making sure that you have a lot of other forage available other than just the brassica cover crop to help sort of dilute that. Okay, so this is the project that I'll be talking about, where we're looking at alternatives to cereal rye monocultures. As I mentioned some of the reasons why we're interested in including winter camelina, and so we're testing some of those things with this project. So this is a 3-year plot scale experiment replicated at 2 sites here in Wisconsin. So Prairie du Sac, which is sort of south central Wisconsin, and then Marshfield, which is more sort of north central Wisconsin. So we have 2 different climates represented here. And we're looking at winter cereal rye, winter triticale, hairy vetch, and winter camelina. And then we have 2 species mixtures with the small grain with hairy vetch. And then we're adding the camelina mixture into each of those for a 3 species mix. And so what are we measuring? So we're measuring spring biomass / forage production. We're looking at the nutritive value of that biomass forage. We're looking at soil nutrient uptake with a special focus on nitrogen and nitrates. We're looking at pollinator resources in the spring, and we're also looking at the impact of these different cover crops treatments on the subsequent corn silage production. And so this is part of a large project that's looking at ways of reducing that negative impact on the next corn crop, and that's really kind of one of the main goals of that project here. So I'll talk a little bit about some of the biodiversity and pollinator work that was done. So this was work done with faculty at University of Wisconsin-Madison and a graduate student. So we're interested in winter camelina for its sort of pollinator value and biodiversity value, right? So what we found was when you have winter camelina alone or in mixtures, and this is winter camelina planted at a rate of about 5 pounds per acre across all treatments that included camelina. So we're keeping the planting rate of camelina consistent, but then we're adding in all these other species, right? So we don't see a difference in floral cover, so it's still producing the same amount of flowers, which isn't entirely surprising. But we're also seeing no difference in pollinator visitation, meaning there's no dilution effect when you have that camelina with other species. Sometimes you would expect that with pollinators if they have a lot of other species sort of diluting the floral resources in that mixture. So we're not seeing differences in pollinator visitation, whether camelina is grown alone or with the mixtures. But what we did see, and this is interesting because this gets back to the fall planting date question. So what we did was we planted camelina at 3 dates at our south central Wisconsin site. So we planted it in mid-September, September 17th, late September, September 28th to the 29th, and then mid-October, which was looks like October 18th. And so what we did find is that the earlier planting of mid-September resulted in earlier flowering of the winter camelina, which then resulted overall in more floral resources for those pollinators for that period of time that we collected data in the spring, which was interesting. And we also collected data from sort of marginal lands, which is basically uncultivated land. So some of the field edges where there was primarily dandelion. And then also we had a no-cover crop control, which is the unseeded fallow in this figure here. So yeah, if you plant earlier, in this case mid-September, you do get earlier floral resources, overall more floral resources, and that does translate to more pollinator visitation. So basically, if you plant it earlier, produce more flowers, the pollinators will visit. And so with the earlier planting, we got more pollinator visitation overall, especially compared to that mid-October. So that's why I said earlier for our site, where we are geographically, I think sort of that early September to very early October is a more ideal time for planting winter Camelina. And these are some of the species that we were seeing on winter Camelina. So the graduate student that worked on this was seeing, honeybees, green bees. We kind of grouped them into these morphological groupings. And a lot of non-bees. And when we talk about non-bees, we mean like syrphids and flies that still act as pollinators that visit some of these flowers. We didn't see a lot of bumblebees on our Camelina, but that's probably because they're just so big and heavy for the flowers that they can't actually hold themselves up on the flowers. And actually, the graduate student observed that a bumblebee trying to visit a flower, but it just couldn't. The flowers just couldn't hold it up. And so this figure on the right is what we call our marginal farmland. So that's primarily dandelion. So we do see some bumblebees on those dandelions, but we see a lot of this similar species visiting both dandelion and Camelina. And again, this is just kind of a picture of a lot of the bees that we were seeing on both the Camelina and then on that marginal farmland that consisted primarily of dandelion. So a lot of very similar species, pretty similar diversity, probably one species more in the marginal farmland. So these are some photos of what those plantings would have looked like. So the early Camelina would have been planted mid-September of 2022. And these photos were taken, I believe that this would probably have been early April of 2023, so last year. And then that later planting, which was mid-October 2022. So you see some differences, but not a ton. But once you get to later in the season, you can start seeing the differences in growth on that earlier planting. It's a lot, further along than the later planting, which then translated to some of the results that I just showed you with the floral resources and also pollinator visits. So that's kind of a nutshell of the pollinator biodiversity information. So we're also looking at forage production. So I don't have all 3 years of the data finalized just yet, but I'm going to show you the results from the first year of the data of the study. So what we're seeing is, and I apologize, I should have converted this to pounds per acre. So what we're seeing here is, for instance, winter triticale on average had about 3,100 pounds per acre of biomass production in the spring. And these were all harvested when winter rye hit the boot stage. So they were all harvested at the same time. And now if you compare winter trip planted alone in terms of biomass production in the spring at that time versus trit with the veg and Camelina, numerically it is a little bit lower, right? So maybe 2,700 pounds per acre, 2,600 pounds per acre. Statistically, it didn't come out different because of the variability, but numerically just a little bit lower. So we're seeing comparable yields in terms of what the statistics are telling us between the monocultures of the two small grains versus when you start adding in the hairy veg and Camelina into the mixture. So that's a positive thing. We're not necessarily giving up a whole lot of biomass production in the spring, and we're also gaining that benefit of the pollinator sort of forage resources for pollinators in the spring as well. And so that's data from 2 of our sites, and we're seeing something pretty similar in that Stratford site. Stratford is our location that's more north central Wisconsin, while Prairie du Sac is our more south central location. So no huge separations there so far. And again, this is just from year 1, and I apologize, there's so much on here, but just I want you to focus just on those highlighted values here on the left, just as an example. So not only are we not giving up a lot of biomass production in the spring by adding those species, we're also not sacrificing some of our forage quality metrics. So for instance, crude protein, if you look at winter cereal rye by itself, it's 9%. But if you look at Camelina, it's actually higher, 12%. And if you look at those mixtures, we're actually seeing numerically values that are a little bit higher, although they don't separate statistically either. So we're not giving up some of our forage quality metrics by including a cover crop like winter Camelina, yet we're still getting some of those other benefits. So that's a positive thing in my view. So the other thing we're looking at that I am not presenting here is sort of, and I mentioned it earlier, just soil nutrients, right? What does this do as a winter cover crop in either planted alone or in these mixtures when you apply dairy manure? Because we're talking about dairy forage systems specifically. Does it help? Is it similar in terms of nutrient uptake as winter rye or winter triticale? And that's some data that we're currently testing for and analyzing. So we hope to have some results from that by the end of the year to report back to folks. And I'll have my email at the end of this presentation for folks that would like to reach out and would like to have some of those results sent to them. So I think really the goal here is that we're looking at it from a sort of a systems perspective. When we add, just simply adding a winter Camelina cover crop, what does that bring? What does that take away from our winter cover crop systems, right? And I think that's really the key here, is that we're trying to look at it from every possible standpoint, from environmentally with the soils, pollinators, and also forage production and value in that sense, and also with the impacts on the corn crop, which I'm not reporting today. And so some of the other work that I'm doing that relates to this, as we saw with winter Camelina, the planting date planting date is really critical, right? And you all as farmers know this. So how do we provide greater flexibility in when we can get those cover crops planted, and provide, one thing I hear a lot from farmers too is sometimes I just don't have time to plant a cover crop because I have too much going on. And that's something that our farm manager has told me before too. So how do you get those cover crops on without taking a lot of that time? Because you can contract now with, as was mentioned earlier, you can contract now with a lot of companies out there are contracting drone seeding. I'm working with a company this year on a robot seeding. So how do we get those cover crops in with the robot between those corn rows? And we hope that the robot will help with that seed to soil contact issue. And also modifying drills, right? So that picture in the middle there shows some cover crops that we interseeded at the V4, V5 stage of corn. So we have some kale, we have some turnips, we had red clover and annual ryegrass in those strips, and they established really nicely. And all we did was we modified our small plot drill here on the bottom middle picture with the orange implement to get those cover crops interseeded. So we're looking at modifying ways to improve modifications to equipment, looking at robots, we're looking at drone seeding. How do we get different cover crops on the landscape within an optimal window that we want them on the landscape for the benefits that we need them for? So that's a lot of work I'm doing currently. Here's a picture of some drone seeding we did last fall. So the picture on the left, well, first I'll show you this. The picture in the middle, hopefully you can see it okay, is our little sort of research scale drone seeder. So it has a small, it's not a very high capacity one. It has a really small hopper on the bottom. We worked with a drone company to manufacture this for us. So we did a small replicated trial last fall with just winter rye, where we looked at different seeding rates and also different timings of drone seeding. And so you can see on the left that we got pretty good coverage actually with those cover crops. And I think that I don't remember the timing on this picture, but that was probably a 40 to 45 pounds an acre of winter cereal rye that was drone seeded last fall. So we're getting pretty good coverage actually with the drone seeding. And then on the right is a field that we didn't replicate. It was just a demonstration field where we drone seeded, looks like winter rye with winter camelina. You can see a little bit of the yellow flowering in there, that in the forefront, and that all that is winter camelina. So it's looking pretty good. Like, I think there is a lot of promise with drone seeding. We're also doing, my program is also looking at seed traits and what makes for a good cover crop or even variety that will be more conducive to drone seeding to get that better seed to soil contact, that maybe take up more of that moisture more quickly. So that's some of the work that we're doing as well. And so, yeah, so these are more resources that I found about winter camelina. So the University of Minnesota, the Forever Green program, has a nice winter camelina growers guide. It's specific to Minnesota, but there's a lot of information on there that can be applicable to just about anywhere. University of Wisconsin Extension has a nice website on winter camelina. The Ag Marketing Service also has some information on winter camelina. And then the NRCS Plant Guide out of Montana has some information on growing camelina as well. So this is my contact information for folks that would be interested, and also I'll also drop it in the chat. But for folks that are interested in getting some more of these results, I'm happy to send the results once we get them summarized. So that's all I have. I'm happy to take questions if we have time, Teresa. I think we have a lot of time.
We actually have quite a bit of time. So if anyone else wants to drop some questions in the chat, we have a few minutes to pick Jose's brain. Margaret Smith has asked or commented, looks as if your turnip NDFD value are for the roots rather than the tops. Any comments on that?
Let me look that slide up here. Well, it could be the combination of the tops and the roots, Margaret, but I don't know for sure. I'd have to look up that extension again. It could very well be a combination of both. Yeah, that's a great question.
While you were speaking, I was kind of wondering, is there like a limit on how far south you can grow winter camelina? I know last winter was the weather conditions in Wisconsin were, very hot, cold, fluctuating. Would this species grow well, like say in Missouri or further south, where they may not have a hard winter? Or do you have any comments on that?
I think from my perspective, Teresa, and I don't know a whole lot about spring camelina, but from my perspective, probably the spring camelina would fit better as you go farther south into Missouri and even farther south from that. I think the winters, the winters
try to keep them north.
Right. I think you would probably want to switch to maybe a spring camelina for climates like that. And there may be, I'm sorry, go ahead.
Go for it. Oh, you go for it.
I was going to say, I think there may be folks doing work down there on maybe spring camelina, but I'm not aware of that.
I know out west they grow both winter and spring camelina in states like Montana, Wyoming, where it's more of a traditional crop that they have growing for oilseed production.
Yes, yes, and it is drought tolerant, right? So it does do well out west, actually. Yeah.
Another one from our forage agronomist. On your forage quality analysis slide, at what plant growth stage or date were these cover crops harvested?
So these were all harvested at the target stage was boot stage for rye. And we had to go with for this particular project, we're kind of had to go with one consistent time. So we decided, because rye hits the boost stage earlier than triticale, we decided to go with that across the board. So we can't really compare rye to trit, but we can compare the rye monoculture with the rye mixtures, for example, and then the trit with the mixtures. But the boot stage and rye was our target, and that's typical for, as you all probably know, for dairy forages.
You know, I have actually heard feedback from farmers anecdotally that they see good weed suppression in fields where they've grown winter camelina, but it is a relatively small plant. It doesn't produce as much biomass as winter rye. Do you think it has any allelopathic compounds, or like what's happening there? If you get a good established stand in the fall and it makes it through winter, does it compete pretty well with weedy species?
From what I've seen very similar things, Teresa. So I don't know about the allelopathy, but I know it does. It can take off fairly quickly if it establishes well in the fall, and unless you have a winter like this winter,
Yeah.
where you get. But normally, if you have a decent winter and it overwinters well, it can take off faster. So I think part of that might just be it's competing some of those weeds in the spring. I don't know that anyone's done any work on the allelopathy part of it, actually. So I can't speak to that, but we have seen pretty good weed control when we have a nice dense stand of camelina. Yeah.
Margaret requested, can you show that forage slide again?
Sure.
She must have a question.
Which one? This one or with the turnips on it?
Margaret, if you're on, can you comment?
The one with the many different species and your mixes.
Did you have a direct question for?
Nope.
Okay.
Nope. Just wanted to look at it again.
So if it's our study, this is the slide here. Yeah.
Yes.
And this is
thank you.
Yeah. Yeah, of course. And so this is just 1 year's worth of data. Not at this point we have, well, soon we'll have 3 years worth of data to be able to summarize a little better, but this just kind of gives you a glimpse to.
Can I make one comment on this? I remember I visited this site 3 years ago. And one thing that I thought was interesting was, you're seeding the rye, vetch, and camelina all together. Sometimes people are worried, the camelina is a very small seed. Can you remind us at what planting depth you were planting these species, especially in the combination mix, and why you think, if you're planting deeper because of the rye and vetch, that hasn't really affected the camelina establishment much, has it?
So we have not. So we're typically seeding between 1/2 inch and 1 inch when we seed. And so far we've had sufficient moisture. So that hasn't been an issue. And we are not seeing that deeper seeding depth affecting the camelina so far. I can't speak to why. I think part of it is, you are, I think this is anecdotal, so I even hesitate to say it, but there is some sort of anecdotal things out there that say, if you have those other seeds that are creating channels for that smaller seed to come through, that can help. Again, that's purely anecdotal. But we're having pretty good luck with those depths, up to 1 inch. So that has not been an issue for us.
Awesome, because I know people want to mix in the camelina, but yeah, some of these species require deeper planting. But yeah, in your research plots, you haven't seen much effect at those deeper planting depths. So lovely. Another question, any idea how winter camelina affects soil microbes, like bacteria and fungi?
Unfortunately, I don't know, but I've actually wondered that myself. As you introduce these different species, ultimately, I would suspect you are altering the soil microbiome, right? You're kind of changing some of the species that are associated with those other species, so I don't know the answer for sure. we are actually our center is getting ready to hire a soil microbiologist in the next year or so that I'm hoping can help answer that question, because I'm also very curious. But I unfortunately don't know the answer to that.
More information to come.
Yes.
I see we have another great question. What seeding rates work best if seeding winter camelina with a drone for, oh, sorry, I skipped over one. Would you have a seed rate recommendation for a combo of rye and camelina that would be harvested for forage?
Well, so and not necessarily for drone seeding, right? Just for any kind of seeding, I suspect.
Yeah, just a standard.
Yeah.
I was starting to read a question I had posed, but I hadn't clicked ask yet. But
Yeah.
I see Denise posted one from Diane. Would you have a seeding rate for, if you're going to grow it for a forage, a winter rye with winter camelina? Like, what would be your forage seeding rate recommendations?
Yeah, I think that's partially going to also depend on sort of what kind of livestock you're feeding and what your ultimate goal is with the forage, right? Right now, for this project, we're just looking at, I think for the 3 species mixture, the rye is being seeded at 50 pounds an acre. Our monocultures are much higher, and then we're just reducing that down as we add other species. But I think the lowest is about 50 pounds per acre with the rye, and then the camelina is at 5 pounds per acre. I think if you have concerns about brassicas, depending on the class of livestock you have, you might even pare that down a little bit on the winter camelina. Plus, that also cuts your cost down a little bit because it is a little bit higher seed cost. So 50 pounds to that 5 pounds is what we need. But with the vetch, in addition to that, so far has worked for us. I haven't played around with the different ratios of those two, however.
I also had another one for you. Would you change your seeding rate if you were seeding with a drone, versus a drill or aerial seeding?
Yeah, typically with drone seeding, you will go higher on your rates. But what I'm seeing even with just this one study is that I think that was probably about 45 pounds per acre of rye. We're still getting pretty decent coverage. Now, we didn't measure forage production potential, right? We didn't clip biomass on those. But you typically do want to seed a little higher with your drone, with the drone if you're seeding aerially. I think it matters less with the camelina because of its small seeded nature, and it's going to establish pretty well as long as your soil conditions are, you have some moisture at least. But yeah, with rye, you probably want to go up a little bit, 60, 75 pounds per acre potentially. I think some farmers are even going much higher than that, 100 pounds plus with drone seeding.
Since we have a little bit of time too, are you evaluating other species for like seeding rate recommendations with your drone?
That is something we're starting right now. Yeah, because there just is not a lot of information out there. There's a lot of, I would say, probably anecdotal and certainly valuable information from some of the drone operator companies that are operating these drones. But I don't know that we really have scientifically based recommendations yet for that, generally speaking. So that is something that we are working on. Absolutely. Yeah. We want to do that for rye. We want to do that for the most common cover crop species, especially the smaller seeded ones that would be most likely to be drone seeded, like was mentioned earlier. We want to kind of fine tune those recommendations for growers.
That sounds great. I know, drones are slightly different from airplanes. So at Albert Lee, we're always recommending the aerial rates, but it will be great to see your research coming up, or maybe other research too, if we get those dialed in a little bit more. Having maybe a drone seeding rate column in the future for recommendations.
Exactly. Yeah.
Well, go for it.
I was gonna say, and that goes along with, there's just so much to drone operations, right? I mean, the speed at which you're flying your drone and the height at which you're flying your drone, which affects the swath width, which impacts your seeding rates. So I think there's just a lot there that can be fine tuned for recommendations. Yeah.
Great. Well, I see we're almost to 1:15. I don't see, oh, maybe one more question just came in. Let me pull it up here.
How's it going?
Oh, I thought I saw, oh, Margaret just says, excited to see and hear about your research. Thank you again, Jose. It's just about 1:15. I think technically we start the next session with Lou from Herzl at 1:30. So maybe we'll just take a brief break.
Teresa?
Yep.
There's another question in the chat there.
Oh, I thought I saw one come in. Let's see. Okay, from Mark. There is an option for market for winter camelina as well. Oh, yeah, there is an option to market winter camelina as a crop as well. Jose, do you have any comments on using winter camelina as an oilseed crop?
Yeah, I mean, I haven't been doing a lot of the that work here. There have been a lot of questions about it though, so I feel like that's something we're probably going to venture into as well, looking at it from the cash crop perspective. But I'll just go back to my previous slide here. Yeah, there's some of that work being done out in Minnesota, North Dakota, Montana, on winter camelina's use as an oilseed crop. There's a lot of value, I think, if it fits in nicely in that sort of winter window period. It matures quickly enough that you could probably either double crop or relay crop it. When I mean relay, meaning you could maybe, for instance, there's work being done on planting soybean into the standing camelina crop so that you get it started earlier. So there are a lot of agronomic things there to be ironed out in terms of competition and nutrient fertility, weed management. But yeah, there is a lot of interest in it, and there is work being done. I haven't done a lot of it myself, but there is some information out there. Some of the resources that I provided, like that University of Minnesota planting guide, I think provide some information that could be useful for folks that are interested in that.
I also know Cargill does have some acres they will be contracting coming up. I don't know if they've released their details yet of the program, but I think in August they'll have a program where they're trying to contract a few thousand acres as they're experimenting with it as an oilseed crop to use for sustainable aviation fuel. But pay attention. There's lots of interest in winter camelina.
Yes.
Another question came in. Can you say anything about how it affects the following crop yields?
Well, some of the work that's been done so far has shown that it works really well with soybean. So it doesn't seem to. I think again it gets down to the agronomics and also cultivar variety selection, right? So a lot of the work I've done is just on Joel, but there are some other varieties that are out there and are being developed. But yeah, if you have like a shorter maturity soybean with the camelina, typically has been shown to work well and no negative effects on it from what we're seeing so far. I'm looking at it specifically in the context of corn. I don't have the results from that so far, but where our hope is that we're not seeing any negative impact on the corn crop after it. And so far we're not seeing that. Of course, in a dry spring like last year, I think it didn't matter which cover crop you had on, because any cover crop was taking up valuable moisture that we didn't replenish. And then I think we're seeing some impacts on the next crop, but otherwise it looks looking fairly promising depending on the crop.
Well, and you guys were in like a D4 drought in certain parts of Wisconsin last year, right?
Yes.
Or it was a pretty severe drought for Wisconsin.
It was, and we totally flipped the switch this year. And it's been our May and June are like our May and June, I think, are the wettest on record in our history. So that says a lot. Yeah. And to your point, Teresa, yes, there are companies out there like Cargill Sustainable Oils is a company out of Montana and others that are contracting with farmers. So if you're a farmer interested in that, that could be a good opportunity.
I think too, from folks I've chatted with, if you can relay crop it or double crop it, it can be a useful growing it in your system to cover the soil through the winter and also have some economic return for you, especially if you can also grow soybeans, again, either intercropped or double cropped. So lots of interesting opportunities with winter camelina. I guess I just thought of a question. Do you have any plots this year of winter camelina, or did your trial just completely conclude?
We don't have any more this year. That one trial, at this point it's just corn, so we don't have any in there. But I might be doing some drone seeding with camelina this fall for next spring.
You know, I'm sorry, I always can come up with questions, but here's another one for you. In Wisconsin, are you really thinking that this would be a good fit after corn silage and then grow it as a cover crop? Or I guess after corn silage and then to be harvested as a forage crop to then go into soybeans? Or where do you see it fitting in the crop rotation in Wisconsin or the upper Midwest?
Well, I think a couple of things. One is certainly after corn silage, there's still time to get it in and for it to establish well, generally speaking. But I also think it has some promise. I think after corn for grain or soybean might be pushing it. But if that doesn't work, I think it really does have a lot of great potential for interseeding type of systems where it can establish well, and then you harvest your cash crop and then keeps growing through the winter. I think it has potential there. I think for us, it's, does it make sense in our cropping systems as another crop to diversify with as a cash crop, right? With a maybe double crop soybean. I think for us, we're testing it as forage just because we're so kind of centered around dairy forage systems, and I think it could bring some value added benefits in terms of the ecosystem services, right? And then still be able to provide that forage, that value added component. So I don't know that I have the answer to necessarily where it would fit in, but I think it could fit in a lot of our cropping systems here in the Midwest or Wisconsin as a double crop system.
Well, and Wade, who was on earlier, he said he never likes to plant a monoculture. He's always trying to include some more species. I think largely in his cover crop mixes, but why not for some forage mixes too? Add a little bit more species diversity, especially when a lot of the forage species kind of overlap with cover crop species. For example, winter rye. People grow it for forage, but they also use it as purely a cover crop. But just if we can add in more diversity, that probably, can have some great ecosystem services provided.
Yeah, exactly. And there is some literature that suggests it does really well at scavenging nutrients. So there is that benefit, right? Strictly as a cover crop or as any other use.
Do you know, as it's scavenging, is it particularly picking up more nitrogen, phosphorus, potassium, micros, or just all of the above?
From what I've read, nitrogen and phosphorus. I think there's still a lot of work that needs to be done on that, but preliminarily, it seems like it does pretty well at picking up nitrogen and phosphorus.
Here we've got a question from Rebecca Sweet. Regarding use of mixes in general, are you concerned about the variable phenology as far as termination timing is concerned? So with different species maturing at different times, when would you terminate such a diverse mix?
Yeah, I guess it depends on your system. So when we harvest as a forage, we're targeting, as I mentioned before, we're targeting that rye boot stage because that's just sort of the optimal time for quality and yield. But I think I don't think I think with things like hairy vetch and winter camelina, I guess I'd be less concerned about the termination timing, because typically, even with like if you had a rye monoculture, you'd probably be terminating fairly early, and even in a planting green situation, you would be probably terminating about the time or around the time we were harvesting it for forage, maybe a little bit later. So I wouldn't be too concerned about the vetch of the winter camelina causing any issues, like being terminated later, because the vetch isn't producing seed by that point, so it's not going to be creating a ton of volunteers, that become a problem. So in this case, I wouldn't foresee that being a problem with the timing. You could terminate a little bit earlier. You could terminate a little bit later, potentially, if you want to plant green.